Okay, hello, and let's talk about Chapter 7, which is going to be our Module 4. Chapter 7 is about normal distribution, the standard normal distributions, and then there are a lot of applications of normal curve, and we're going to do some examples here. Start with the normal distribution first. Well, we all know that the normal distribution has a curve that is bell-shaped, and one of the key components of this curve is that this point here is the mode, because obviously it has the highest frequency. It is also the mean and the median, and so this right here is the mean, it is the median and the mode. Because this is the median, and we remember that median is the 50th percentile, then in terms of probability, the area under this curve represents the probability. And remember, the sum of probability should be 1. Therefore, the mean, which is also, by the way, the median, splits the curve in 2 segments, and the area under each segment, each of these 2 segments, is 0.5. So in other words, a normal curve is symmetric about the mean, median, or the mode. Okay, so let's quickly jump into some of the probability questions we're going to be dealing with. So for example, let's say here we have a normal distribution, and let's say that our mean is 10. The question could be, what is the probability that, let's say, x is greater than 4? In other words, we need to find the probability that x is greater than 4 based on this normal distribution that has the mean at 10. So, before we try to find this probability, one of the most important thing is in normal distribution is you should always have the mean and also the standard deviation for it. So we don't know the standard deviation in this case, but right now we're just going to try to see where this region lies on this curve. So let's see. This is 10. So obviously 4 is going to be towards the left somewhere. And remember, I said that the probability is the area under the curve. So probability of x greater than 4 is going to be x is greater than 4, which is in this direction. So that probability is this. Let's do another one. Let's do probability of x less than 9. Well, 9 again is going to be towards the left of 10, so it's going to be somewhere here. And the probability of x less than 9, so x has a value that's less than 9, so it's going to be in this direction, and the probability is denoted by this area. So that's the general theme behind trying to find these probabilities. The first thing you want to always do when you're solving these problems is draw it out, and it's going to help tremendously before you try to find the probability. So now let's talk a little bit about standard normal. Well, standard normal distribution is a special type of normal distribution, and it has a mean of 0 and a standard deviation of 1, and it's denoted by the letter Z. So if the mean is 0, obviously the mode is 0 and the median is 0, and every other property of normal distribution holds in this case. There are again two segments. This segment has a probability of 0.5. This also has a probability of 0.5. One of the interesting things about normal distribution is you can have any other normal distribution. So let's say, let's go back to our original distribution with mu 10. Any other distribution can be converted to z distribution. And in fact, what happens is when we try to find the probabilities, we always do this conversion. It's we're lucky that we have technology. We have Excel, we have TI-83, 84, where in some cases we don't have to do this conversion because the software does it in the background. But the rule is that you convert every other distribution into z, and then we have tables provided to us in the back of the book that we can use to calculate the probabilities. But in this class, we're gonna go with the technology because it's available, and why not use it? Why make life difficult for us? So, but when we do this conversion, it is important to visualize the conversion, though. So, as a quick example, I'm going to show you that this is 10. This is the same distribution, by the way. I'm going to draw a z right under it. And let's assume that the standard deviation for this distribution is 2. So now let's try to find probability that x is less than, let's say, 8. So we need probability that x is less than 8. So obviously the first step, we're not going to find the probability, we're going to try to find the region that represents probability of x less than 8. So that region, the way we do this conversion to z is using the z-score formula. So it's x minus mu divided by the standard deviation. So in this case, our x is 8, our mu was 10, and our standard deviation was given as 2. So this is minus 2 over 2, and it's minus 1. In other words, the value of x less than 8 in the x normal distribution is represented by the value of minus 1 in the z normal distribution. So if x is here somewhere, this is 8, and the region we are interested in is this, then the same region can be shown on the z distribution because we did the conversion. This point is minus 1, which is, it lies pretty much at the same point as the x, and obviously we are interested in this area. So it's just important to know that this conversion can be done, and this is what the technology does. So we're going to use the norm dist function. In order to find this, we know that the norm dist function expects an x value, then it expects the mean, then the standard deviation, and then the cumulative option. We're going to use a cumulative option in this, and I'm going to convert it into 2 diagrams. Mu is 0. Remember, this is the 2.04. If I can find this area, all of this area, and then find this area, So if I find the first area, let's call that A, which is less than 2.4, and then if I find the area less than minus 2.4, which let's say is B, and if I subtract the B from A, I'll get the area that I'm interested in. So in other words, it's going to be norm dist with 2.04, mean is 0, standard deviation is 1. Cumulative option, I'm going to set it to 1 or true. They're both the same. So this will give me all of this area, everything from here and this area too. So everything on this side. But now if I take this area, which I can calculate as norm dist minus 2.04, 0, 1, and 1, which will give me this area, which is B. So this is B and this is A. And then I just need to subtract the two to get my answer. The answer to this is 19793. The answer to this is 0.02067. And the region that I'm interested in is this minus that, which is 0.9587. Pretty straightforward. There's nothing really behind it. And this mean and this standard deviation, you can use any number. So if some other distribution is given to you with the mean of, remember in the previous case, mean of 10 and standard deviation of 2, you can put that here and it'll give you the probability. So straightforward, not much behind it. And the only other thing we need to do possibly is take the same case. Let's say that I know that this probability is 0.8 and I need to find this point. And Excel obviously has a function for that too, and it's called norm INV. And norm INV is pretty straightforward. It expects an x value. So in this case, it expects the p-value. In this case is 0.8, and it always expects the cumulative p-value, so less than on this side. So it's 0.8. It expects the mean, which is going to be 0, because again we're interested in z, and the standard deviation, which is 1. And this will give you your answer. If we have the case where we are interested in this x value, where we're given this area now, and let's say this area is 0.3. So the p value is 0.3. So we're given p of x, sum x is 0.3. X greater than xa is 0.3. How do we find this? Well, we know this area is 0.3, then this area has to be 0.7 because it's 1 minus 0.3, so it's 0.7. And again, I can use the norm INV 0.701 to get my answer. So I hope this will help you out in solving the problems and solving the assessment questions. Try to do the examples that are on the blackboard. They're going to help you tremendously. I've solved quite a few of them. And if you have any questions, feel free to get in touch with me.